talk about how we'll go from Java 8 to Java 16. That's the presentation from my side. Again, if there are any questions, you can ask. Okay, so let's see. A little bit of background. I was writing Java since 5 years ago. I was still writing some Java code, but there was after that I made a pause. And these days I'm writing more JavaScript, if you want, than Java, pure Java. But anyway, I was checking yesterday the JDK from Oracle, and as an update for everyone, we have Java 16, the latest feature. Which some of them are preview, some of them are final version, but that's with us, asking mark there. Then there is the Java 11, which is the long-term support, and probably we'll talk with Luis after, but I suppose this is what should be used in production. And then the Java 8 is the legacy support. Also, we have a nice timeline. I took this from an article, and you have the link in my article to this. So basically, you can see that there is a 6 months release cycle since 2017, since Java 9. And this will continue, and I think that's a great approach because you can get the latest features and also you got the stable builds. Okay, but now let's see what we got in the main feature edit in each of these versions. So we have for Java 8 lambdas, collection strings, a method reference, probably the most big update. And I was playing with an example, so you can see on the left. It's a simple. So we have an array. We are initializing with 0 to 9, and then we are writing the actually, yeah, we are supposed to write the output there from the list. I just see there's a small issue mistake there. It's just system out print line I. It should be data get I. Okay, anyway, on the right you can see the same code wrote with the stream. So we initialize an int stream. We just say, okay, give us a range from 0 to 10, and for each of this range we add a value to a list, which is nice, but we can do it better. So we can use the method operator, just a second, the method reference, and these are the double quotes. So we can say in string for each list, the sign to, and then we can say add. And this basically what we'll do, we'll take each of the in-stream element, and we call the list.add and that element for each of the elements in this case. And you can see below, you can show all of them with print line, and I think this is a nice construction in the last line. So we can say, okay, for each system out, print line method, send each of the list element, and it's nice because it's just printing all the elements there. For Java 9, they enter the private method. Initially, I was not. If you play with this, does not make any sense initially, because okay, what will be the scope of a private method if I cannot call you from anywhere else since it's private, right? But looks like that there is also the default method. So you can write a default method in an interface, which basically provides a default implementation, and you can use that default implementation to call the private method. So in the left side, you can see we have a private method called correction, for example, and we apply it to a real square. So we have the default implementation. We'll call the perfect area and then apply a correction. And of course, perfect area is not defined here. And you can see the definition in the real square implementation on the right. And yeah, it's working just fine. You can call it. And you can see just right down on the right side down, you can see the square, and we call the perfect area and the real square area, and it's working great. Okay, and then on the Java 10, they got closer to the JavaScript, and we have the var support. So instead of saying, okay, this is an int stream, you can just say var, and whatever it is, it's dynamically initialized. If you are using a tool like, an editor like from JetBrains, IntelliJ, they will actually highlight there on the var that it's an int stream. Pretty nice. On Java 11, that's also pretty interesting. You can call Java without compiling it, so you can call Java main.java and we just run it. The only problem that I got, and I think there should be a solution, but I didn't find it myself, is if you have any reference to an interface, to whatever, it seems that in the same folder they don't know it, so somehow you need to infer to put it there. Okay, and then Java 13, so I'll see Java 12. I didn't find anything special. In Java 13, we have switch, we return values, which is an interesting construction. So you can see here we have a switch, and for red we return a value, for blue another one, for the default another one. And it's pretty simple, and we can also actually use it. For example, in Java 14, they added the record support. Record support is also interesting because creates for you all the get and all the constructor for and you have just to define it as a method. So basically here, public record square inside string color, it's actually a class, but is okay. So basically the extra info is just the color, an extra method, whatever, and then you can use it as a normal. So sqr color is not get color, it's color, and also you can call that method. Seal classes is interesting because it limits who's implementing a given interface. In our case, for example, the square interface, we can allow just real square and second square to be implemented. Also, this can apply to abstract classes. So the seal keyword can be applied to abstract classes. Yeah, basically this is it.